Hey, welcome back. Hope you guys are doing absolutely great. Sorry, I wasn't able to upload videos for a month or so because life got me very busy, and you know what? The situation of COVID 19 in India is not really that great. We are having a really large spikes now, and yeah, sitting alone in home is kind of depressing sometimes, right? So that's what was the problem, and I also had some lot of tasks. I wrote some Ruby gems for the Arduino. Okay, so it's a task manager kind of thing, and for that I was kind of busy. But I think I should be able to make videos from now on, most likely. And I will probably finish off the Ruby C extension part, and then I will copy the whole thing to the Ruby gems, and I will create a gem with the Ruby C extension, just like my other gems like Linux stat, for example. Anyway, without any further ado, let's get started with the utsname.h header file, which lets you see the utilization of your Linux system. I mean, the various status like the node name, like your other things. Like if you just Google it for utsname.h, you will get it. And as you can see, we can see the system name, node name, release version, machine. And as I told it, it doesn't actually show you the system utilization, it shows you system basic details. So anyway, you can see this information, but to do that in Ruby, you can also use the HC class, I mean the HC module, right? So if I run IRB and require HC, and as you can see, it is already required by IRB. But if you just Google for HC Ruby, you can see that it can do a lot of things. Like for example, if you run hc.uname, you can see that system name is Linux, node name is Boron. In my case, it is Arch Linux, I guess. So if I run hc.sysuname, I get a whole lot of details like that. And this is actually utilizing the uname.h header file on Linux. I'm not certain about the things like Mac OS, Windows, or even BSDs or Unix, other Unixes. But I can guarantee that this works perfectly fine for any Linux distribution. Even this works on Termux on your Android phone. So now I want to create this thing on Ruby C extension. In your case, it is just for learning. It is like reinventing the wheel for learning purpose. And I'm going to reinvent the wheel for the learning purpose. If you were writing a quick script, you can just use hc.uname, right? So without any further ado, let's create one directory called uname, cd into uname. Now let's create our xtconf.rb file. Let's edit it with nano and require mkmf, and then we are going to create make file called uname. Now do note that the module we are going to use, the C module, is called actually utsname.h. It is not uname, right? It is utsname.h. So that's what we are going to call our module. Let's create our C file called uname.h, I mean uname.c, and let's include our good old stdio.h for printing purpose, and include our maybe just stick with the utsname.h file for now, because we are not going to create our Ruby module at first. Let's see how it works, and then we are going to create Ruby functions out of that. So first, let's create our main function, which will not run with Ruby because Ruby defines it. And let's create our buffer. So to create our buffer, we will do struct utsname, I guess, or maybe uname. Let me see. Yeah, so we have a structure called utsname, and let's call it buff, right? Now we have to actually call the uname function, I believe. as you can see, it is int uname, so it returns an integer. The integer is determines the status of the uname function. So if uname fails, it will return probably -1. You can see in the return, for example, it doesn't list that, but you can use the man page for that, which is really great. So if you go to the man page, man7.org, you can see that uname returns system information. All right, that's not a big deal, but on errors, on success, you get the 0 value. So it is an integer, it gets 0 if it is succeeded, but on error -1 is returned. So it either returns 0 or -1, it doesn't matter. It will never ever return 1 or something like that. Now let's actually declare our short variable, or maybe character variable. So we call it character status. So it will store the status here. Let's just give the address of our buffer here, and if I do printf %s, because we are going to print a string, and if I do buff dot as you can see, I remember these things, but I'm just referencing the guide, because you can see from where I'm fetching all these things. So if I do buff.sysname, it should print the whatever we had in our etc. Hope you remember, or maybe not. It will have the Linux sysname, right? So if I run gccp.c, sorry, it is called uname.c &&a.out, you can see that we have no such file or directory, because I made a big mistake. It is, as you can see, it is sysutsname, right? So you have to use sysutsname.h. Now, after compiling and running, you can see that it returns Linux. I mean, buff.sysname is a string that stores the Linux. Let's copy this whole thing, maybe paste it 5 times, and let's print our node name. Let's print our release. Let's print our version, and let's print our machine. So if I just print them, you will see that we have the exact same thing that our etc returned. I mean, we already have the etc in IRB, so I don't have to require that every time. You can see that we have Linux, we have Arch Linux, we have the kernel version, we have the kernel build date, and we have the machine x86-64. If you're running on maybe on a Raspberry Pi or maybe on your phone, you will see it differently. Output might vary for you, but it is correct actually. Now, as you can see, it prints x86-64, which is perfectly fine. But if you are actually writing an OS kind of gem and you want to check the Ruby version, I mean the Ruby platform, right? So you can do this x86-64 and check if it has x86-64. So it is a 64-bit operating system, right? But wrong. This approach has a lot of problem, which number one is that you can compile Ruby 32-bit and your x86-64 can differ. I am not sure about that, but I think this is not a really good solution. You can always use the etc thing, etc uname and machine, which will give you x86-64 no matter what your Ruby compiler was. But as you can see, etc uname is actually x86-64 and it is not dependent on what Ruby you are using. On JRuby, for example, if you run Ruby platform, it will show JRuby, but etc will not do something like that. Now let's edit our file and remove our main. Okay, let's call it init uname, because in the previous file on the xtconf.rb we have called it uname, and it should be uname like that. So if I define a function, let's call it something like sysname, and it should return a value. Let's first also include our ruby.h, and let's create the function sysname, and it will return a string value. So if I do struct utsname buff, and now let's have a status uname ampersand buff, and then if status equals to 0, so we are checking if this has actually succeeded, we will return the rbstr new cstr, and let's convert buff dot sysname to the Ruby string. We can also refactor our code. Just a moment. If return status equals to 0, we'll return rbstr new cstr buff.sysname. Otherwise, we'll return maybe an empty string, right? rbstr new cstr an empty string. So it can be done in one line. So it always return the value, either the sysname or an empty string. So if it returns an empty string, you will know that your sysname is something wrong, or it cannot be fetched from uname. So maybe you have done something weird on your system. Now let's remove this code from here, and let's first define our maybe call it rb define global function. Let's call it sysname, and it will call sysname. It takes 0 arguments. Also, we need to add the volatile value. Let's call it obj. It doesn't matter, but we have to always use the obj, because in most cases this function calls will send something to obj, right? It is the main in our case. So if I let's compile and run our code, we can just remove the stdio.h from now, because we are not printing anything, we are not using something like that. And let's compile our code with ruby xtconf.rb ampersand make. As you can see, it is compiled. If I do ruby -r, and let's look at the uname.so, or we can remove the so, and if I do sysname psysname, you see it is Linux. So if I again edit my code, and let's paste it 5 times, and this second one should return the node name, the final should return the release, the fourth one should return the version, the fifth one should the fifth one, let's paste it, and the fifth one should return the mission. And also we have to make sure we modify this code, I mean mission. This should be the version, this should be release, this should be node name, and this should be the system, right? Which is already here. And if I let's define our functions 5 times. Sysname, node name, release, version, mission. If I use VS Code here, I can just grab the whole thing and rename it everywhere, every single operation, which was really great, but I really nano for simplicity, because device name really doesn't matter. Now I think this is done. So if I compile around this code again, and to compile we will do this, and let's copy it, ampersand, and you can see that we have Linux. We also have the node name. I mean, we can create one array, right? This name, node name, release, version, and mission. As you can see, it prints these things very well, and this returns an array, but you can also use a hash, and you can also use rb hash asset to set the hash items. And also you can use this struct utsname buff, and you can define it constant, right? And you can remove all this code from here. So it is shorter but make sure you have to call the uname buff every time, because otherwise it is going to mess up, right? um Now if I compile and run this code again, um it has some problem, which is okay. So we are defining constant, but we shouldn't, because we are actually modifying the address of buff, right? So as you can see, we have the exact same thing. You can also set the sysname as a constant, because let's create a function. It will return nothing. Let's call it get stat, or maybe init stat, something like that. I don't know, I'm pretty much not creative about naming stuff. And if I create some um, constant string, let's call them something like sysname release, I mean node name release, and then the version and mission. And when I call this function, it will just initialize the buffer, and then it will set the sysname equals to buff dot sysname. It will set the node name to buff dot node name. It will set release to buff dot release. And then we are also going to have version equal to buff dot version, and mission equals to buff dot mission. Now we have set these variables when you call this function, so we will always we will not call the uname again, right? And also make sure that if status equals to 0, then we are going to do this. Otherwise, if status isn't 0, we are not going to set these things like this. So in this case, I will write the else. We can also avoid the else and return, but which is not very clear. I mean, I can just return and then omit the else, right? But that's not very clear, so I'll not do that. And in these cases, I'll just maybe I can do one more thing. I can remove this, and I can just set them all to a empty string. Okay, let's wait 1 moment. And I just avoided whole thing if the status isn't 0. So we will call init stat once in this function here. And when we call these functions, we will return rb str new cstr buff dot sysname, then the the sysname here. Let's read our login from the login variable. We can remove the text here and remove the mission guest. And this caveat as well, I'll set as later on. Now, we can do the correct things, right? We have to make sure we remove the if conditions statement. Now, every data is initialized. We'll have this data changed, the system node name, etc., etc. Let's append one underscore so that we don't have any confliction with our function names. Sorry, it is taking some long time, but hopefully you are learning something from these videos. I can just probably compile and run this code. Let's see. we have expected semicolon on line 27. Okay, so I just forgot the semicolon while removing stuff, and as you can see, we can have the exact same thing when we compile the previous code, right? Now there's a caveat, as I told before, which is you can also set this node name to something like rb str new cstr, right? um, Assuming that the node name is actually a value defined here, just like this. Instead of car, we will have node name without, maybe we'll have sysname without any asterisk. But in this case, we'll have a really big problem, which is the garbage collector. So in our case, the garbage collector will get the values and it will remove it from our Ruby environment. So in that case, you may see random garbage values. You can say that the garbage collector compacted, and you will see that it has some other string from other Ruby gems or maybe from the IRB itself, which is not really good. And also, when you just garbage collected something, you will crash your whole Ruby environment. So I'll just ask you to stay refrain from that practice, to declare things above, so that you might think that it will avoid calling the rbstr new cstr function, right, which will be faster. But it will be faster for sure, but it will be more buggier and less reliable, and also it could be a security issue, right? So that's how we can create our uname. We have just replicated our etc, but instead of defining our hash, we just created function names. Now in the previous videos, I have showed you how to create hash, how to set items to the hash. You can just do that very easily, but let's stick to the functions right now. Hopefully you have learned something new. If so, please don't hesitate to like, share, and comment the video. And I hope to see you in the next video. Thank you very much for watching.